So on the one hand, we have this JUnit test case, TestProduct3, and we're going to set a breakpoint in a moment. On the other hand, I try to put everything relevant on the paper for our tracing purpose. So you can see here for the template definition, we have the product class for the model package. And this section here are all the attributes. This is the overloaded constructor. And these are all the mutators, and these are all the accessors. I try to resort them so it's easier for us to see the different categories of methods. And this part here is the JUnit test case we're considering, TestProduct3. And I try to include all the assertions that we have spoken about in the previous video. So I'll try to trace line by line. Let me now, first of all, go back to the JUnit test case, and I would like to put the breakpoints on at line number 80. But if you don't have the same line number, that's okay. Put it in the at the point where right before the execution of the first line, where we are trying to create P using the overloaded constructor. Okay, and I'm going to run between the debugger and the paper side by side. All right, so how do we launch this JUnit test case? We haven't seen so far how you can debug a JUnit test case. I would say the way you debug the JUnit test case is just like how you debug any Java class. For example, the console application that we did before. Either you can simply make sure the current selected class is the JUnit test class, and then you can simply click on the bug button here. But to be more safe, if you want to make sure you're really debugging the right class, you can right click on the test class and you can say debug as JUnit test. So that's the way I'm gonna start. Okay, I'm gonna initiate the debugger, and then do you want to switch the perspective from Java into debugger? Yes, I want to. And let's now switch. All right, so let me just make this panel here a little bit narrower over here so I can see as much of the editor of the class as possible. Okay, by the way, while you're debugging, you should not really try to make any changes to your Java class. You should always, if you want to make any changes, you should always click on stop and then switch back to Java perspective before you start editing again. Otherwise, you will actually mess up with the debugger. All right. We are now at this point here, right before we try to create this new object of products and save its address into the object variable P. And we spoke about how you can trace this in the earlier video. So I'm going to bypass the detail for the memory diagram. Okay. But what I want to show you is, right now, if I simply say step over, don't do it just yet. If I say step over, it's going to bypass the execution of this overloaded constructor. But I want to show you very quickly. Okay. Remember, we spoke about in the earlier video, you can break this particular line into three parts. Part number one, about a new object creation. Part number two, about declaring the object variable. And part number three, which is the most crucial, to really store the address of the new objects into this object variable, right? That's what I spoke about when I traced the object creation earlier. Right now, what I want to do is go in, what I want to step into. If I say step into, now I'm now in the context of it's actually a string. The reason I got a string class over here is because I actually got a new string over here. So you actually step into the string constructor, but I don't need it. So whenever you want to bypass this particular library class execution, this is where you can say step return or step out. I can say step return. So now I'm now back to this line. I just step return from this particular new constructor call, right? I want to step into again so that I can go into this overloaded constructor. So let me say step into, right? So now I'm now in the context of the product class, and I'm now right before I try to execute this particular overloaded constructor. Only got two lines. What I want to draw your attention to is under the variables over here, you can see the this. That's a context object, and I spoke before. Now, if we let me just go back to test products here. If I look at this particular line, what is the context object when I'm trying to create a new product objects? The context object, it really is this particular object over here I'm creating, right? So now I already got some address for that. So now if I go back to the debugger over here, you can see if I see this is the context objects, and I don't really have the address over here. You can see here, this is just about the output from the ToString, since already defined that. But what if you really want to see the address for this product object here, for the context object? you want to see its address rather than the string description. That's something I showed you earlier. Let me just mention that quickly. What you can do is go to the product class, which I'm here, and then you want to comment out the redefinition for the toString method here. You can comment it out, and then if you relaunch the debugger, you're going to see the address. That's what you can do. You should really be familiar with both ways, either with the toString method by default, or maybe the redefined version like this definition here. All right. Let me go back here, and this is where the breakpoint is. And what I will do is I'm just going to make a note of ID 65. In some way, the unique ID here can also be understood as like an address, like a 65. Okay. So what I will do is I can see that what we have done is we are trying to create this particular product objects. So let me just now try to draw that. Okay. So this is the how do we draw the object diagram. That's the slides I asked you to review in the earlier video. So now is the time to practice that. What should be the structure for each product object? As we mentioned before, it should be, let me highlight it, it should be determined by the list of attributes. And we got 6 attributes over here. That's why we actually got 6 different fields over here. 6. Okay. What should be one of each one of them? Model, finish, storage, has cellular connectivity, original price, and discount value. I'm just going to write it in the short form. So it's going to be the model, and also finish, storage, and also has cellular connectivity, and also original price, discount price. Okay, I'm just going to put it like that. But you can see at the runtime there's going to be 6 different fragments in the object structure for the products. And we know that the ID is 65. So what I would do is for the address, you can just know that it's about 65. Some symbolic address in the memory that's unique. And we are actually going to execute these 2 lines. And you can think about the this over here. These 2 this, right? We are now executing this. Let me just highlight what I'm trying to execute right now. You can see what we are talking about is this line in the unit JUnit test. And then we are passing these 2 input values, and then we are calling this overloaded version of the constructor. That's what we are doing, right? And input number 1, this will be replacing the model over here on the right hand side for the assignments. Input value number 2 is going to replace original price here and the original price here, right? I'm not going to write it down. It will take too much space. And the this over here really is the context object over here with the address 65, and we're going to set its model and also original price to these 2 input value. So it's going to be iPad Pro 12.9, and for the original price it's going to be 1709. So 1709.00. That's what we have. All right. And then we're also going to, let's just execute that very quickly. And I mentioned it to you before. You can see the model and the original price. Currently, they're still having the default value since we haven't executed these 2 lines just yet. But let's do that now. So if I say step over, step over, step over, you can see these 2 values have been set already, right? Okay. And then I'm going to say step over and step over. Now I'm done with the first line of execution. This somehow has been done earlier, but I was using the computer memory diagram. But now this is a high-level tracing you should really get yourself familiar with. And of course, we are storing the address of 65 into this object variable p, right? Diagrammatically, what I would do is I'm going to say p over here, and that stores the reference of this object. So it indirectly points to this particular object. That's how we draw the diagram. All right. We only got a single object to consider in this example here, but we'll see how we can call different methods on this context objects. So let's see one by one. Let's just see on the debugger very quickly, and I'll show you some interesting bit. Okay, let's go back to debugger, and now we are right before executing this line over here, and we want to see whether this will be assertion will be passing or failing. Right? You can definitely see the variables, but in the variables you don't see the result for method call, right? You can only see P over here. You can see the P, the model is actually iPad Pro 12.9. That's actually kind of indirect. what you can do instead is go to the expressions panel over here, which would be very useful. In case you don't see the expressions panel, what you should do is go to the Eclipse and go to Window, go to Show View, and you can click on Expressions. Expressions over here in the middle. All right, click on that, and then you can drag and drop to this right beside the variables. Expression is very useful. And now I can put whatever expression that would make sense in the current context, in the current method, or in the current class. So currently I'm now in the context of TestProduct.java, and I'm in this particular method. So P will actually in the scope. So I can definitely use P. So I can say, for example, P dot get model over here. And that one's giving me iPad Pro 12.9, that's a string value. But what if I want to assert it is not null, right? For example, I can also do whatever expression I like. I can say p.get model, right? It's a string value equals null. It would be false. On the other hand, if I say p.get model not equal to null, it's going to be true, right? You can do whatever expressions you like as long as they're valid. Okay, so that's why if I simply just go over, I don't have any exception. I don't have any failure. So that's why I can simply pass them without any trouble. Okay, hopefully you're fine so far. And why don't we try? And you can also copy this expression here, copy that, and then you can paste it over here. That will also give you true. So that means this Boolean expression will evaluate to true, which can be asserted to pass for assert true. Okay, so that's about it. And let me now go back to the tracing on the paper and see. Let's say we want to trace this accessor call. Let's say p.getModel. Okay, so this is our first time tracing a method call. So let's be very careful. Okay, so when we say p.getModel, let me just make it a little bit bigger for you. Okay, over here, so you can see the dot. So as I mentioned earlier, dot notation is like looking up the address that is stored in the variable of the context object, which is p. So when I say p.getModel, it really means I'm going to look up the address that is stored in p and follow that pointer to this particular objects. So that's what I'm doing here. So I'll get into this particular objects. So that's p dot, and I want to call getModel over here. And the getModel is actually one of the accessor method over here, getModel. So this is the accessor method, right? So now if you look at this, so here we got this dot model. What's this? This is the context objects. So when we actually try to call p.getModel, p over here is the context objects. Let me write it down here. So the p over here is the context objects. And so in this case, we're going to replace the this over here by p. So that means we're returning p.model. What's p.model? P.model will be, so as after we say p dot, and then model is going to give you this particular string value, which is iPad Pro 12.9, and then it is not null, of course. All right. And similarly, if I try to do the similar lookup, p.getModel 12.9, iPad 12.9 compared with this value here, of course assert equal will pass, right? Hopefully you get an idea. Let me move on. And then p.getModel over here is also the iPad Pro 12.9, and then compare that with this particular string, and that will also give you true. All right, and I'm just going to maybe execute this very quickly, and then this is our first mutator call, p.setFinish. How is that going to work? In a similar way, let's say p here is the context object, right? So that means we're going to actually say p dot, so we get to this particular objects, and then we're going to say setFinish. So where is the setFinish? setFinish is here. Let me try to find it for you. It's a mutator method here, setFinish. And what is this? This is actually the p, the context object. We are dealing with the same context objects. But you should really know that, otherwise, when we actually got multiple objects in the context, you will get confused. So this will be replaced by p. So we really got p dot finish is assigned to finish. And what's this finish over here? This finish, let me use a different color. So this finish over here corresponds to the input parameter. And this is actually the space gray that we are passing over here, right? So what we are trying to do is finish over here will be simply the space gray. And p.finish is referring to this attribute over here, and it's going to be replaced by space gray. All right. So after this, the way we check it will be very similar as before. So if you say p.getFinish, in that case, you're going to get this string value back, which is not null, right? If you try to follow through the assertions, it's going to work just like a get model as before. So I'm not going to bother you with that, right? Let's just highlight it. So p.getFinish over here, and also p.getFinish, and also p.getFinish. Okay. Let's now move a little bit quicker. So now that you know how to judge about the context objects, let's see another mutator call. Why don't we just try to see the eclipse very quickly about the mutator call, and then we'll come back. Okay. And don't forget the ID value for this object here is 65. That could be useful for later. Let's now go back to Eclipse, and then now if I want to trace for p.setFinish, which is a little bit behind on the debugger, but let's now catch up. If I try to step into, I want to see exactly how p.setFinish is being executed. I can say step into. So now I'm not in the context of the product class, right? If I go to variables, if I see this is with ID 65. So we are talking about the same objects for the context. And at the moment, this dot finish is actually null, right? And then I'm going to execute this line. This dot finish is assigned to finish. That's exactly what I just traced. And that's going to change that into space gray. All right. So hopefully you are not lost. Okay, step over, step over, step over, step over. I can tell you that everything is going to be fine. But the only thing I want to go a little bit further would be the cellular connectivity. I'll get there in a moment. Let me just finish tracing on the paper, right? Let's now try to see this. And this can be done very quickly. p.setStorage to be 1000. So the context objects is the same, just p. So that means we are still talking about this particular object here. And we are trying to set its storage with 1000. So we are calling this setStorage method here. And then so storage will be 1000. So that means this storage, what's this? This will be p over here. So we are really doing p.storage is assigned to 1000. Diagrammatically, how do we update it? So p.storage is assigned to 1000. Okay, that's what we have done. And later on, if you try to make the accessor call, p.getStorage will be 1000 equals 1000 should be true. And p.getStorage should be 1000 and is really matching the expected value 1000. So that's okay. And also, that's good. Okay. And let's now trace this line here. p.set has cellular connectivity. This one, we are also updating the same context object again, and then set it to be true. So the mutated method we're talking about is this one here, right? And then we want to set it to be true, right? You can see the true here. So we're going to set this to be true. I'll just say T for short. So the right-hand side for the assignment should be true. And this should be just P, right? Then since we got P here. So P dot has cellular connectivity should be assigned to true. So P dot cellular connectivity should be assigned to true. Good. And now I would like to go over the mind teaser together with you in case you were confused in the earlier video. I think that this might be a good time to also see how we can evaluate those. Let me just highlight p dot has cellular connectivity over here. And let me highlight all the occurrences of them over here. And now you can see very clearly about how I can judge whether they should pass the assertion or not. And p dot has cellular connectivity, and p dot has cellular connectivity. Okay, good. Every one of them is simply just going to be true. Agree? As we said, right? Every one of them, the context object is simply just p. So they will just return true. So now the first case, assert false, and then I will say not true, which will be false. So that will pass. The second one, true equals false, which will be false. So assert false is going to pass. The third one, true equals true will be true. So assert true is going to pass. Next one, true not equals false is going to be false. It's going to be true not equal to false is going to be true, right? They are not equal. And also true equals false is going to be false. However, we got this negation over here. Negating false will give us true. That's why it also pass. Okay, final one. So here, this part over here is actually true, right? And then negate it to be false. Negate false will give us true. Double negation. So that's why assert true still is true. All right. So hopefully you can see how we can use the paper tracing so usefully. Of course, how would you do this on Eclipse? That's also something I would like to show you for completeness. Let's now go back to Eclipse. Okay, so now we are here. Let me just go further over here. So set storage, we have talked about it already. So now after p.set, okay, let's say p here, p dot has cellular connectivity is currently false. If I execute by stepping over, it's going to become true, right? You can see now has become true over here. Let's see each one of them. You can, again, make use of the expressions panel, right? Let's say you don't want the earlier one, you can simply highlight them and then remove them. You can say remove all. What about the first one? I can predict what's going to happen. So now I'm pausing here right before executing this assertion. But I can try to predict what's going to happen. For example, I can say p dot has cellular connectivity. And that's going to be true. But what if I add an exclamation mark before that? Let me add it here. That's going to flip it to false, right? And you can try all the expressions I have over here to see whether they should be true or false, right? I'll leave that to you. All right, and then let me just go all the way to over here for the debugger. Okay, so this one should be quite obvious because get original price is going to return the original price value, which has been set by the overloaded constructor already, right? You can see here. Let me just go back here quickly. So here, if I say p.get original price, and again, we're talking about the same context object p, and then p.original price is referring to this attribute here, which is this value over here, right? That's exactly equal to the expected value. So that's why it will pass. A final mutator method call, which will be p.set discount value over here. Context object again is p. And next week we'll see in a piece of code you might have different objects that can be the candidates as a context object, which we'll see. So p here, okay, we're still talking about this object here, and set discount value to be 220.00. So that means we are executing set discount value, which is over here, right? And we want to set it to be 220. So this will be 220.00. So that means the right hand side is going to be 220.00. And what's this? This is going to be replaced by the context objects, which is p. So p dot discount value is assigned to this particular value. So let's do that. P dot discount value is going to be assigned to 220.00. All right. And a final method to really show to you, a final two methods quickly, which will be, let's say p dot, of course, if you say p dot get discount value, that should be 220. That one's easy. What about p dot get price over here? It might be worth tracing this one again. Let's see. So p dot get price, we are still talking about this context object here, and then get price. So this is not about just returning the attribute value, it's about doing some computation. Let's see where get price is. So get price is this accessor method over here. That one takes no parameters, which is good. But every occurrence of this, the context object should be replaced by p. Let's do that. So you can see this here should be P, and this here should be P, right? So what we're doing is we have some price variable here. Initially 0.0, and then it's going to be reassigned to P dot. You can see P dot original price minus P dot discount value. Okay, let's see. P dot original price, which is this value, minus P dot discount value, which is this value. If you do the math, you're gonna see exactly the expected value over here, right? I'm gonna let you check the math. I'm pretty sure that's correct. All right, and finally, the method to call would be the ToString. So P dot ToString, and this one here, the only thing I want to highlight to you is that this keyword can be implicit if we don't have any variable shadowing. So what do I mean? So P here is a context object, right? It's again this object here, and we are calling the ToString method here, right? It's quite big. Let me just try to box it properly. So this will be the ToString method, okay? And then you can see, for example, let's see the model here. I didn't really have this, but if you go back to Eclipse, let me just show you. If you go back to the product class and go to the ToString method, if I move my cursor over model, it's going to also highlight the model attribute that's declared over here. So I'm really talking about the attributes. So that means in this case, since there's no variable shadowing, either you say this the model or model, they can be used interchangeably. Okay. So implicitly, let's go back here. Implicitly is really like a this dot model. And what's this? This in this case is the P. Okay. So this will just be replaced by P. So I'm really talking about P dot model. And what's P dot model? P dot model is referring to iPad Pro 12.9. So if you look into all the references to the attributes over here without this, they're going to be traced in the same way. And eventually, what you will get is you're going to get this particular expression value. Okay. Let me show you one more thing on the Eclipse. Let me go back to test products, and then I'm now currently here. Let me say step over, step over, step over, step over, right? Over here. And if I say step into, I'm now in the ToString method. If I move my mouse over the model, so this is the model, it will show me it's iPad Pro 12.9. If I look at the finish, if I move my cursor over finish, it's actually space gray, right? There are many things you can actually look into on the Eclipse debugger. It's very, very useful. And also for the expression, what you like is, let me try if this will work. I can copy the entire expression, don't include a semicolon at the end. I can now copy that, and then add new expression. I can simply paste. Let's see if that might work. Yeah, exactly. So if I click on that, that's exactly the ToString expression string value I will get return over here. That's exactly a string value. All right. Okay, that's about it. And let me step over, step over, step over, step over. Okay, that's the last assertion. If I can simply step over, there's no failure, so everything just passed through like a charm. So if I can just stop the debugger over here, and I'll switch to the Java perspective. All right, so that's about the complete tracing of this JUnit test method between the debugger and also the paper. So the reason I really want to spend the time with you on this example here is because to show you, you should really understand the correspondence between the paper and the debugger. They definitely should be consistent with each other. So that's about the final part for this week, for part 1 of this review tutorial series. For next week, we are going to start talking about how we can declare some reference variable inside your class, and also how we can define reference and multi-valued attributes in your class. That's something we'll do for the second part of the review tutorial. Stay tuned.